Alright, let's look at the homework 6.3, problem number 5. Alright, so we're going to use the midpoint rule with n equals 5 to approximate the volume of the solid of revolution. Alright, so let's do that here. Alright, so first let's draw a picture. So we have let's draw the y-axis first. Here's the y-axis. And here's the x-axis. Alright, and then the curve is y equals square root of 3 plus 2x cubed. So I believe it's going to look kind of like that. Let's see, kind of like this. Alright. Then it's going, x is between 0 and 1. So we are looking at the 1 here. And so this is the region. Alright, so this is the region. And we are rotating about the y-axis. Alright, so we are rotating this way. Alright, so if you look at the sample x, then the sample shell, approximating shell, is going to look like this. Right? So let's set up the integral. So integral is going to be, alright, start with 2 pi as usual, integral, and the region starts from 0, ends at 1, right? The radius is again x, and the height is determined by this curve here, which is square root of 3 plus 2x cubed, right? So that's the height. And then we're doing it with respect to x, right? So this is the integral we want to approximate, right? So what we're going to do is let's use the, let's say, midpoint rule and with n equals 5. So we're trying to find this guy, m5, right? Actually, I'm going to squeeze everyone inside, so it's going to be an integral from 0 to 1. And 2 pi x square root of 3 plus 2x cubed dx. Right? So I'm going to call this integrand, so this guy right here, I'm going to call it f of x. Right? Then if you want to find the m5, what we're going to do is we take the interval from 0 to 1, because that's the interval there, and split that into 5 pieces. So it's going to be 0.2, 0.4, 0.6, and then 0.8, right? So midpoint would be, so it's going to be 0.1 here, and this is going to be 0.3, and this is going to be 0.5, this is 0.7, and this is 0.9, right? Then delta x is going to be this much, so delta x is definitely just the 1 divided by 5, so 0.2, right? No, sorry, 0.2 I meant. Right, 0.2. Alright, so m5 is going to be simply, right, evaluate the function at 0.1 and evaluate the function at 0.3 and at the 0.5 and at the 0.7 and at the 0.9. Then dx is going to be just 0.2. Right? So let's compute this using a graphing calculator. Right? Alright, so I brought out a calculator here. Alright, first thing I would do is I'm gonna define a function. So what you can do is go to y, right? Then get rid of the old stuff. Alright, so we're gonna type in this integrand, which is 2 pi. So 2 and pi. So there should be pi somewhere here. So it's a second and a half. So 2 pi. Then you have x. then you have a square root. So let's see, where's the square root? Here. So second, and x squared gives you square root. And then I'm going to put the 3 plus 2x squared. And actually this is cubed, so you have to do a hat 3. Alright, then go here. Alright, so this is the integrand, so I'm going to probably just say enter. Alright, so y1 is the function. Right? Then what we want to do is we want to do this computation. So I'm going to second and mode to quit to go to the regular screen. Then what I'm going to do is I'm going to put the parenthesis. Right? Then we're going to do, we have to pull out that function. So we have to go to vars. Right? Go to y var. And 1 is the function here. Right? So we plug in 0.1, right? And plus, and do that again, and y bar, and 1, and 1, right? Then we put 0.3, right? And the plus, and var, right? Y bar, function, the very first function. Then you put 0.5, and plus, right, vars, right, y bar, and function, and the first one. So this is going to be 0.7, and the plus the last one, vars, y bars, function, and the first one. Right, then we put the 0.9, right, then close parentheses. Then we just have to multiply by 0.2, right? Then hit enter. Right? So it came out to be, say, let's see, we want to round it to 2 decimal places. So it looks like it's going to be 6.09. So this is going to be about 6.09. Right? So that will be the volume of this approximation anyway, using a midpoint rule. Right? So let's type it in to double check. Right, so we'll go to here, and what we got was 6.09. Right, let's submit for testing. Right, it came back and looks like we got this one correctly. Right, that's it. I hope that this was clear.